Hello student. In today's session, we start new chapter from syllabus of 11th standard and it is chapter number 1, units and measurements. The weightage of this chapter in examination is 5 mark without option and with option 7. Now let's see here the curiosity. Curiosity leads us towards science. And what is science first? Basically, science is systematic knowledge of the physical or material world gained through observation and experiment. So here in science, observation and experiments are very important. Now observation. So whatever we observe need not be always correct. In physics, we have to learn whatever we observe, whatever we see in a surrounding. So this observation need not be always correct. Means sometime maybe whatever we see, maybe it is not correct. Let's see one example. When we observe a railway track, it does not appear to be parallel. Let's see a picture of railway track. So these railway tracks are not parallel, but actually you know that they are parallel. Means whatever we observe here in this case of railway track is wrong. But actually the tracks are parallel. So we can't just trust on observation. Experiment is also important when we are verifying something in science. So experiment is a major part of the physics. Basically, so you have in final examination also, you have to write theory as well as you have to do the practical examination also. Because experiment is essential. You can learn lots of things by experiments only. Now, let's see measurement. What exactly the measurement is? Basically, the measurement is comparison between known and unknown quantity is the measurement. When we are going in a market and we purchase something, the shopkeeper measure it. Shopkeeper is measuring that means what? He's a comparing with the known and unknown. Let's see some example about the measurement. When we are measuring the height of a person, that time we are comparing known and unknown. Now, how we are comparing known and unknown? Basically, the scale is known for us and the height of the person is unknown. When we compare these two, then we can conclude some measurement. The height of the person is 6 feet, 5 feet, 4 feet, etc. Means we are measuring something, means we are comparing known with unknown. Let's see another example. So we are measuring something here. So you can see here, we are measuring some object, mass of the object. Then that object we can place in one pan of this measuring weight balance, and in another pan we can keep a known weight, means known thing we can keep. When both are balanced, we can say that the measurement of or this mass of this object is dot dot kg. Measurement means the comparison that you remember here in simple life. So what is the need of the measurement? So we can write a full essay on the need of measurement in day-to-day life. But basically, we are not going in day-to-day life examples here. So you know that in day-to-day life, we measure everything. We measure milk, we measure the size of the clothes, etc. We measure the size of the footwear. So every individual having a different measurement of clothes, footwear, etc. So this measurement is a very important part of this day-to-day life. We can write 5 pages, 6 pages essay on that. But here we are not dealing with that day-to-day life measurement need. Here, what is the need of measurement in science or need of measurement in physics? Basically, in physics or in science, measurement is used to predict laws, scientific laws. For example, Ohm's law, Joule's law, Newton's law, how the scientists predicted the laws. They are taken a measurement and they concluded something. And these conclusions are called as laws. Basically, Measurement is also useful to verify the scientific laws. If Ohm predicted his law, it doesn't mean that someone can believe on Ohm's blindly. We can verify it. How we verify it? Again, we can take the measurement and then we can verify whether the predicted law is correct or not. So it is used to verify the scientific laws. In a practicals also, you have to verify many things. So here, need of the measurement is to predict the laws and to verify the laws, or to predict some things and verify the things. The measurement is very important. Now, when we are measuring something, in that measurement, basically, uh, we which quantities we can measure. These quantities are coming under the physical quantities. So, physical quantity means the any quantity which we able to measure is a physical quantity. Basically, you can measure length. So length is a physical quantity. We can measure mass, velocity, temperature, area, volume, density, etc. The whatever the quantities we able to measure, that are coming under these physical quantities. Then non-physical quantities means which we are unable to measure. For example, love. We cannot measure love, success, like, emotions of person. We can compare, but we cannot measure. So in physics, we are dealing with only the physical quantities. Non-physical quantities we are not dealing with, that you know. Now when we are measuring anything, in that measurement, unit is playing very important role. Now what is unit? Basically, unit is standard used for measurement of physical quantity. We are not measuring non-physical quantity, that way. Standard used for measurement of physical quantity is called as unit. For example, unit of length is meter, centimeter, or kilometer. These are the generally used unit for the length. Unit of mass is gram, kilogram. So everyone know the standard units. Now these are the standard units. Basically, what are the requirement for being a standard unit? You know that in villages, when we go in a villages, they are using a different unit to measure length. They are using a different things to measure, a different unit to measure the mass. But these units are not the standard units. Then whatever the units we are using in the physics, these are the standard units. Then what are the requirement for being a standard unit that we have to discuss under this topic? So basically, the first requirement is the unit should be universally accepted. So this is very important requirement. Universally accepted means it must be accepted by all the countries. You know that unit of the length is meter. So meter is accepted by all the countries. India, Pakistan, or any other China. In every country, the meter unit you can observe. So it is universally accepted unit. Second one is unit should be invariable. Invariable with time and place. Time or place. Invariable means not changing with time. It means that before 1 hour, the 1 meter is that much, and after 1 hour, the 1 meter is that much. So it is not possible. It should be invariable. Before and after any time, it must be same. So it must be invariable. Invariable with time. It must be invariable with place also. In India, 1 meter is smaller as compared to the China. That is not possible. Then it is not the standard unit. That is unit is a standard means meter is a standard unit because it is invariable with time, invariable with place. So it is a standard unit. Means if we go on any place, it is invariable. It is same. So that unit is only the standard unit. So here unit must be universal, means it must be invariable. Next one, the unit should be easily reproducible. So easily reproducible means we can make a copies of that unit. For example, so you know that 1 kg, if I given you 1 kg to you, definitely you able to make uh, 2-3 copies of 1 kg easily by using a metal, by using a stone also. As well as if I given you a meter scale and if I ask you make one more meter scale, you can easily copy it. So it should be easily reproduced. Then only it is a standard unit. Now next one is it should be well defined. Well defined means 1 meter means how much? It must be well defined. No confusion in that definition. So it should be well defined. Then only it is standard unit. You know that meter, kilogram, second, these are the standard unit. You can search on Google a definition of 1 meter. Then you come to know that the definition of 1 meter is fixed. Definition of 1 kg is also fixed. So they are the well-defined units. Then after that, the physical quantity. Basically, we already discussed the quantities which we can measure directly or indirectly. These are the physical quantities. Basically, physical quantities are classified here in two categories: fundamental quantities and derived quantities. Fundamental means basic and derived means that also we have to learn after some time. So let's see more about the fundamental. Fundamental means which do not depend. The quantities which do not depend on other quantities for their measure, they are called as fundamental. So unit of fundamental quantity is fundamental unit. Now what are the fundamental? It's basically which we can measure directly. For example, if someone asks measure the length of the bench, you can directly measure by a scale. Measure mass, you can directly measure temperature, you can measure it directly. The quantity which we can measure directly without taking help of other quantities, these are fundamental quantities. The second one is derived. Now, what are derived? Basically, derived means which depends upon one or more fundamental quantities. Physical quantities which depends on one or more fundamental quantities, they are derived. Now let's see some example, then the concept is clear. Area. You know that if someone asks you find out the area of the bench, then you can take a measurement of length of the bench, then you can take a measurement of breadth of the bench, then you can multiply length and breadth, then you get area of that bench or that table. Similar man, if someone asks you find out the density, then you can find out mass, volume, and then you can take a division of mass and volume, because you know that formula of the density is mass upon volume. Means to measure this density, we have to take help of two fundamental quantities. Means two quantities. This is the mass, and the second quantity is useful is the volume. So volume is not the fundamental, but we require the use of two quantities, mass and volume. Then force, acceleration, work. These are the derived quantities. Only 7 fundamental quantities are there. Except these 7, all are derived. These 7 fundamental quantities we have to learn under this one of the system of the unit. Under the SI system, we have to learn these 7 fundamental quantities. And unit of this derived quantity is called as derived unit. Now, various systems of unit. In that, we can discuss the systems which are the existing systems of unit are there. The first one is CGS. Second system of unit is MKS system. Third system of unit is FPS system. Now fourth system, and it is the recent system, is the SI system. In older days, some countries are using CGS, some are using MKS, some are using FPS. So when scientists exchanging their data, they are finding difficulties. So later on, a SI system is introduced, and nowadays every country following this SI system. Now let me learn more detail about these various systems. So first we start with CGS system. Now CGS system. In this CGS system, we are considering only 3 fundamental quantity. First one is length, mass, and third is the time. three fundamental quantities, and their units are centimeter, gram, and second. So centimeter C, gram G, and second S. By using these three letters, we can name it CGS system. CGS means C for centimeter, G for gram, and S for second. So CGS means in this system, length, mass, and time are measured in centimeter, gram, and second respectively. Now, similarly, the next system of unit is MKS system. In that also we are using uh, three fundamental quantities: length, mass, and time. Length measured in meter, mass measured in kilogram, time measured in second. Now, after this MKS, next one is FPS. So this is a British system. In this, again, length, mass, and time, these three are the fundamental quantities, and they are measured in foot, pound, and second respectively. So this is FPS system. Now after that FPS, next one is SI. So since use of different system of unit become very inconvenient for exchanging scientific information that we already discussed between the two countries, the most convenient system was accepted and is known as SI system. So it is accepted in 1960 at 11th International Conference of Weight and Measures, which is conducted in Paris. So its long form is Lee System International D Unit. Now let's see more detail about the SI system. Now in that SI system, so seven fundamental quantities are there and two supplementary quantities. Now let's see the fundamental quantities, their SI unit we have to see, and the symbol of that SI unit. The first fundamental quantity is length, and unit of length is meter, which is similar to the MKS, and symbol of the meter is M. Now second fundamental quantity is mass, unit is kilogram, and unit is symbol is kg. Third is time, unit is second, and symbol is S. These three fundamental quantities are same to the MKS system. Now, in addition to these three, more four quantities are there. The fourth one is temperature, or we can say that thermodynamic temperature. Basically, temperature in SI system is measured in Kelvin. Kelvin is the name of scientist. So, by the memory of the name of the scientist, we are using capital K as a symbol of temperature. Capital K for Kelvin. Amount of substance. Amount of substance is measured in mole, and symbol for the mole is MOL. Mole. Sixth fundamental quantity in the SI system is electric current. Electric current is measured in ampere. Again, ampere is the name of scientist. So we are using capital A as a symbol of ampere. Now, seventh and the last fundamental quantity in the SI system is luminous intensity. Basically, what is luminous intensity? This term is new to you. So, it is the measure of intensity or brightness of light. In simple word, you can remember it is the brightness of light. And SI unit is candela. Symbol of that unit is CD. I told you, in addition to these seven fundamental, two supplementary quantities are, and the first supplementary quantity is plane angle. Plane angle, unit of the plane angle is radian. Now, what is a plane angle? That we discuss later, but what is the unit of plane angle? It is a radian. And in short, a symbol we write rad. Second one is solid angle. The unit of the solid angle is steradian and symbol is SR. Now after that, let me learn more about some these two supplementary quantities and the plane angle. So plane angle is the angle between two planes. If I consider this is the first notebook page and this is second notebook page, then angle between these two notebook page is the plane angle. So basically, plane angle we can write like arc by radius. So if this angle is d theta, then this arc is ds and this distance is r. Then we can write plane angle ds by r. You already seen this formula in geometry also. Then after that, solid angle. Now, solid angle is angle, means three-dimensional angle we can say, or angle inside the ice cream cone is a solid angle. So here you can see d omega we can use for this solid angle. So this is the area that I represented by dA. Then solid angle formula is dA divided by this r. So this is solid angle. So this area divided by this r square is the solid angle. SI unit is steradian that we already discussed. So if we are talking about the solid angle subtended by this sphere, the solid angle subtended by sphere is area is that 4 pi r square and divided by this r square. R square get cancelled. 4 pi is the solid angle by the sphere or spherical body. Now after that solid angle, we have to go for some rules to write SI unit or convention for use of SI unit. When we are writing SI unit, what rules we have to follow? These rules we have to learn. The rule number one, the unit of every physical quantity should be represented by its symbol. Means when we are writing any physical quantity, generally we use symbol. For example, unit of volume is cubic meter. This is a unit of volume. We can write it like this, meter cube. We write it by symbol. Second rule, full name of unit. Basically, full name of unit always start with smaller letter, even if unit is given after the name of person. For example, here, Newton. So 1 Newton. So it should start, means it start with smaller letter. Or all letter we have to write small letters when we are writing full form of the unit. So we cannot write like this, 1 Newton. This Newton full capital N is wrong, means 1 Newton. So this Newton is the name of the scientist. It is not the unit. So when we want to write a unit as a Newton, then we have to use small n. So Joule, similar manner for the Joule. Joule is also name of scientist. So always you have to use small letters when we are writing any SI. Rule number three. Symbol for the unit named after a person should be in capital letter. Means for example, when you are writing a symbol of unit Newton, we have to write it in capital letter. For example, here, N is for Newton. After the name of scientist Newton, the unit is given, Newton unit is given to the physical quantity force. So when we are writing Newton, symbol we have to write in capital letter. So if you see the symbol in capital letter, you remember this is the unit given after the name of person. Now after that, rule number four. Now rule number four, symbol for unit do not take plural form. Means always unit we have to write in singular form. For example here, so force is 20 Newton. You cannot write 20 Newtons or 20 Newtons. Always in singular form. Do not take plural. Always it is in singular form, that you remember. Similar manner, when we are measuring the length, if it is 1 meter or 20 meter or 30 meter, always meter, not meters, that you remember. Always in singular form. Now rule number 5, symbol for unit do not contain any full stop at the end. For example, so 25 kg. So you cannot write 25 kg. So you know that kg is a short form of kilogram, but you are not allowed to put a full stop after this kg. So full stop not allowed. As well as a punctuation mark also not allowed while writing this SI unit. So next one is the unit of physical quantities in numerator or denominator should be written as 1 ratio. For example, SI unit of acceleration is meter per second square. You can write like this well, but not like this. You know that acceleration, meter per second. Two times you are not allowed to write. It must be as a one ratio. Always. Rule number 7. Use of combination of units and symbols for units is avoided. Means combination of units and symbols avoided. So let's see one example here. The unit joule, kg, Kelvin is there. This is the correct way. But here we are writing a unit joule in full form, and then per kg. This is symbol. This is again symbol. The combination of these full form and symbols are not allowed. So that you note here. Now rule number 8. A prefix symbol is used before the symbol of the unit. Thus prefix symbol and unit symbol constitute a new symbol for the unit, which can be raised to a positive or negative power of 10. For example, we are writing prefix here. So 1 millisecond. So the full form is 1 millisecond. So millisecond, milli means milli is a prefix. So generally use prefix milli, micro, nano, pico, etc. So milli. So milli means 10 raised to minus, and this second as it is. So 1 millisecond. So this M stand for 10 raised to minus. So and this second as it is. So micro. So this micro is the prefix. So micro means 10 raised to minus 6, and this second as it is. Nano means 10 raised to minus 5. We can use a prefixes before the unit. Next rule is use of double prefixes is avoided. Double prefixes. For example, you can see here. So 10 raised to minus 6 second. You can write it like this, but you cannot write like this. 1 mms. So someone can say that, sir, it is millisecond. So this is a wrong way. So double prefixes you have to avoid.